Gender, age,
location, like area you live in.
Cool. Yeah, it's a good point.
Color.
What?
Color.
The color? Yeah, that's a good point. Anything else you think are critical?
type of car.
What is that?
The
Type?
Yeah.
Yeah, cool.
History of accidents.
Yeah, that's a good point. The past claims, like accidents. So basically there are two categories, right? The vehicle and the customer. So vehicle, like it could be make, model, type, size, value, and etc. Customers, the age, where you live, your credit score, the past claims. But obviously it also depends on what kind of coverage you want, right? So this is just like a very simple example. Like I think everybody can understand how the data science, like good models, can help the insurance company. Okay, so
the model
this is another project I was working on, understanding driving behaviors. It's using the telematics data. So I don't know how many you have got a little device from the insurance company that they said you just need to plug into a car, they give you a discount, right? Okay, so how does it work? Because you consent, you give him the data. They will collect your data and analyze your behavior and give you a discount. So the project we're working on is just using this data, but I mean, this data are always like secure. So we don't know like where are they from, and we don't even know any customer information, just like each individual in the database. So we use the telematics data. So basically, it's just recording your speed and your location. As I remember it was collected every second. So with that data, that's just like billions of rows data. So we are able to just extract different kind of features to represent what kind of people you are, like what kind of driving behavior you are. So we do two things. One is supervised trip classification. Like we know, we get all the trip data you have drive before, and we know there's a unique pattern of yourself that the model to build model, that model to analyze. And if there's a new trip coming, we know like this who drive this car, right? So we give you got the insurance for your car, and someday you have a family member, your friends drive a car, it could be easily detected because I mean unless they have the same driving behavior as yours. The other one is the unsupervised driving behavior clustering. So this one is we did not make any assumption. We just put the data together. We extract few dimensions of features and applying unsupervised learning to analyze this big amount of data and let it to generate like how many groups out there. Like we don't define like there are 5 kind of people. We just like let data tell there are 4 or 5 type of behaviors and then how each of them associate with different driving like risk score. Right? But those two are just like research projects. I don't know if they bring them online or like how much did they improve. But I just want to show you like what people in insurance could play with the data and how they use that to make their decision better. Okay, so challenges. It looks like the machine learning is so powerful in the insurance, but there's still like challenges we need to face. The first one is data quality, because the insurance, the industry has been a very old traditional area which have a lot of data, especially for those like claim nodes. They're just like a kind of messy. So you need to be very careful when you use those data, and the quality is the issue. And the second is like the interpretability and the transparency. So that's it's partially coming from the regulation, partially coming from the company, because they don't they usually not happy with the black box algorithm. Like you told them I build a fancy sophisticated model, you give my features, you output the precise outcome, but you just cannot explain what happened inside the model. That's usually not acceptable. So even for today, like some neural network or some like random forest, people are trying to develop tools to reveal what happened inside the algorithm, try to make them transparent. But yeah, so there's still like an issue people are concerned with. So next is data science in digital marketing. So first, what is digital marketing? I'm just talking about like the high level of the digital marketing company do. So the goal for this company is to help business reach their goal target audience, increase their online visibility, generate leads, and ultimately increase revenue. Right? So the digital marketing companies, they use data-driven strategies and tools to optimize the campaign and to maximize their clients' return of investment. I put a screenshot on the right. You can see this today. I just opened the CNN website, and on the right part, you can see that's the 2 ads that pushed to me. But you may not be able to see this because it's personalized. It's only pushed to me. One is about coffee, the other one is about the HBO, asked me to subscribe. So I just want to tell you that this is an online ad, and this is one of the things that digital marketing companies are doing. So there are usually 3 ways to do that. Online ads, the email campaign, like you receive the email promotion, and or the mail. That is pretty traditional, like people send you the envelopes with promotions. That is not that popular these days. Okay, so what does the data science help the digital marketing to the business? In 3 different ways: customer targeting, product recommendation, and ad bidding optimization. So customer targeting, this is easy to understand. The company helps their clients to target and serve their potential customers, right? So for example, your client is just making up Walmart. Walmart says, I have some budget, just push the ads to the right customer, right? So for the digital company itself, the data scientists want to build models. They collect the data from people's some browsing, their past purchases, demographic. There's all kinds of data. It could be first-party, third-party data, and to build model and to predict for each person like how likely they are going to purchase from Walmart in the next few days. And if you have a very high likelihood, I will just send the ads to you to increase the revenue. That's the customer targeting. The next is the product recommendation. Can you use the same example, the Walmart, because the Walmart sells so many items, you cannot easily tell person is very likely to purchase from Walmart, but maybe from specific department of Walmart, right? So I want to promote the televisions in Walmart. So in this way, you are not only targeting the right person, but you're also give them the appropriate products in order to increase their likelihood to go and buy. Okay, and last one is the ad bidding optimization. So this is more like what I have received when I surf the CNN website. So whenever I load the website, and the CNN always have this advertisement spot there, and those digital ads companies have seen I go to CNN, and they will bid for this spot. Right? So as long as their price gets accepted, they bid for this one, and they put their clients' advertisement there, which is more like have interest to me. So this is like more like a real-time calculation bidding. So in this way, data scientists try to build a super fast and but could be very simple model, and to do the online calculation and give the best price to get that ad served to you. So that's pretty much like 3 different parts that data science have worked on. And let's see, what is the challenges? The first one is performance, not revenue. Like as a data scientist, we build models and we evaluate the models, right? Like for you could use like say accuracy, precision, recall for the classification problems, and usually use this metrics to evaluate the model performance. But this does not guarantee the revenue increase, right? So one typical example is the client wants you to target the right customer, and you just pull out their all past customers, and you serve ads to them. So the model is good because most of them have returned to the store to buy. But it means that if you don't serve them the ads, they will still come, right? They still, because they are loyal, like customers. So in this way, you spend the budget, you get the served ads, but it's not leads to the revenue increase. That's one challenge, which makes like the data science, when they build model, they should carefully choose their metrics, not only using their statistical metrics, but also some business KPI. Second, acquire new customer. So this is really hard, like when we build model, to say we want to target new customers who has not purchased from our client before, right? Because there are so few data, you don't have their price, you don't have their purchase history, you don't have how to analyze their interest. So in this way, but they acquire new customers. This is the really need from client. They don't want you to analyze their existing customers. They have their own departments. They want you to acquire new customers. The next is efficiency. As I said, like for the online ad bidding, you really need to make your model fancy, but also as fast as possible. And the last one is identification. So this one is a little bit irrelevant because, like for the online ads, like the Google Chrome or the Apple Safari, they have adopt more and more like privacy policies, which makes those digital marketing companies really hard to identify people. Like they use the browser cookie ID, but it's really hard now. It's become more and more difficult to identify people. It's not trying to identify who are the person, but it's just like a link all the information together, like the purchase with the browsing history, this kind of stuff. Next, cloud computing. So this is like the area I'm working on now. So just in case you have not know too much about cloud computing, so simply say it's like the cloud computing is the delivery of computing services, including servers, storage, database, networking, software, and analytics and intelligence over the internet, over the cloud, over faster, flexible resource and economies of scale. So like you typically pay what you use. Help you to lower your operation costs. So more and more companies, they're just using the cloud. They don't need to build their own cluster. They don't need to have to hire their own operating engineers. And so in this market, the leading companies, AWS, Amazon Web Services, Azure, Microsoft Azure, GCP, the Google Cloud Platform, Oracle Cloud, and also many other companies. And the data science or the machine learning also have a lot of application in this area, including the analytic platform. So this is very obvious. As the cloud itself, you need to provide those analytic capabilities, right? Like for your customers to use, you probably provide those algorithms, provide those pre-trained models so that they can use immediately. Resource optimization, as in Microsoft Azure, we have millions of machines, and when there are like millions of customers that are using your cloud, you really need to better allocate resources, right, and to avoid any those outages. And the last one is cloud security. This one is also critical. You don't want anything bad happen to your cloud, anything like cause the outage of your cloud, which is bringing really bad thing to the customers. Okay, so what the things we are doing, we just keep it high level. We'll not cover details. So we are doing deployment safety. So deployment, if you are not familiar with that, you can think of deployment, the software deployment as a Windows system update. Like when you probably sometimes you got the notification from Windows laptop say your system need update and you click that. So that's kind of but this is on the system level. It could be on the service and the infrastructure is a lot of outside. So we want to make sure those deployments will not cause any harm to the other machine. So what the node will not cause a faster outage. We're not covering details. So we are doing that. But that's basic problem. It's very vague, right? We need to make it more specific. We need to define, for data science, we need to define what is health data. You measure the machine. how it is healthy or unhealthy, how do you define that, and the deployment risk, how do you define that, whether deployment is good or bad. And besides that, you need to collect the mission data. There are sort of numerous data. You collect mission data from hardware, from infrastructure, from system, from networking, all images. And you will need to correlate the deployment with mission data. Like, the mission was good, but after deployment, the mission was down. But we cannot simply say your deployment cost the mission. We need to exclude all other external factors. So by excluding all those stuff, and you see there's only like one deployment going on the machine. And in this way, with this like a causal relationship, we are confident that your deployment probably has a problem. Can you fix that before you roll to the whole cloud? Right? And the next is experimentation evaluation. How do you use the experimentation to test your model, not just test machine in production, not just push a bad payload to production to hold how fast as possible, and how to evaluate what kind of measures you design to evaluate results.
So by excluding all those stuff and
so what I try to do is using work in this way, meaningful data collection.
With this
So here is
we are confident the department probably has some problem. You fix that?
It's not that you don't have data, but you have too much data.
Right. And the next is experimentation.
Computer running,
How do you use
record so much data, and you cannot use all of them. That's impossible. You see that scalability. So try to extract the meaningful data collection experimentation platform. How do you, as you say, introduce in the above section, the experimentation platform and machine logs utilization? You want to analyze how healthy a machine is, and you collect data from different dimensions. But the most comprehensive data will be the machine logs or the run logs. But if you collect them and you have millions of machines, that's just too much, and you want to develop some way to analyze the logs, but those logs are not like the natural database as machine learning. And for your own business need, you will need to develop ways how to analyze those logs. Okay, besides model, so I've introduced a few cases about the different industries, but they are more about the model building, application engineering. But as I said, the data science world is way more than just feature engineering and building model. You are also doing a visualization, reporting, those database, data pipeline, integration of data engineering work, and also we work on like the big data platforms.
And for your own business, you will need to develop a way how to analyze those logs.
Yeah, so these are just three very universal requirements to become data scientist or good data scientist. It's very straightforward. You need statistics, you need machine learning knowledge, and you know how to program, and you know the big data platform like Spark, assembly, and Kafka, which will makes you capable of end-to-end data science, not just some research. But there's some more from my personal thoughts. Problem-solving skills. How do you address business problem? You are not given a problem by a manager. Like just a business problem. How will you break the goals down into small pieces and solve them one by one? And the next is know what you need. So this is tricky, like when
you know how to program, and you know
do some course assignments or do some practice, you are given the data, you are given the goal, you are asked to build a model. In reality, you will decide what kind of data you are the data scientist. Sometimes you have the engineer, data engineer, you have the data software engineer to support you to get this data ready, to get the data scalable, but they cannot decide what data you need to tell them. So that's kind of the thing, like you are the owner of the project. And the next is know what you need from end to end. You will collect the data you need, and you will establish the evaluation. Do some report to the stakeholders. Last one, domain knowledge, not only data driven. So in the companies they like to hire data scientists with some experience in the same area. That's because with those expertise, it's very easy to combine with the data-driven solutions. You cannot fully rely on data. So data-driven is what we want, but that's not always correct. And if you have the domain knowledge, you're easily to validate those patterns or insights you find from data, and you can better combine with them to generate the best solution, not just based on empirical experience, not solely on data-driven.
The companies tend to like to hire data scientists with some experience in the same area.
So these are
that's because with those
my
expertise,
opinions
it's
about
very easy to combine
thoughts about this area. It's not accurate from others' point of view. I cannot guarantee that this is my personal thought. The first one is data science is not all. I should say that data science is not magic. Like you cannot think that data science can solve every problem. Storing some data to the model and it is automatically generating all the results for you. That's not the case. Okay, so data science in the industry is more like optimization. You are trying to improve the model, improve the business model. While in some cases it's like even without the data science, the company still works well. They just use very simple rule-based models, or they use simple linear regression. Still works very well. So that's possible. When you prepare the data science, it's not magic, not solve everything. Second, data is greater than the model. That means data is more important than the model. People say garbage in, garbage out. You have to look for the data source, and you will find it's possible that you spend much effort to build a fancy, sophisticated model and you find the performance you compare with the linear regression is trivial. That's possible. And the two possibilities. One is the data is too good, and whichever model you use, and it will already give you good performance. Or like the data is static, it's not having any information. Whatever models you have, it's not going to work.
Data is more important than model.
Next, you spend most of the time on data, not model. That's by my experience. I'm also doing offline research when I do work. But modeling plus research probably just take my 5 to 10% time. Most of the time it's exploring data, writing code, for the pipeline, for the visualization, reporting, this kind of stuff. But I just want to say that these are all meaningful. You cannot spend too much time on modeling, which can be easily replaced. Last one, explain the model and insights. Yeah, this is also very important. Like just as I mentioned before, you cannot just say, I'm putting the data into the model and it gives me a very accurate result. That's not enough. You really need to find a way to expand the model, why it performs well, and how does each feature impact the final result. And besides the model, we are not just building models. We are also providing insights. We are giving the large amount of data. It's also possible you're not doing any modeling, but just extracting those insights with the hidden patterns under the data and give those suggestions to your partner team, to engineering, to let them to develop the product. That's also possible.
Putting the data into the model and
okay, I think that's all my slides today. I hope I can give you some useful information, and if you plan to do some similar stuff in the future, I hope they are somehow useful as well.
We are not just building models, we are also providing insights. We are giving the large amount of data. Any model, but just extract insights from the hidden patterns of the data and give those suggestions to your pilot team, engineers, to let them to develop this product. That's also possible.
Most of the learning?
Yes. Okay, I think that's all my slides today. I hope
I think from the two parts, the first part is you will always be to
do something
like
similar stuff
because you are scientists.
I hope
you are engineering good people will ask you to do. You find something new and which can be developed into some new product. So that's very rewarding, but that's very hard. And the other one is to build, I would say, end-to-end service product. That's also very good. So my opinion about data science is that you cannot only focus on just build some overall things, or build model and have the software engineer to build a discipline. So you are able to build from the scratch from data to the final output. And if that was the building on the service, I think that's really satisfying.
Some new product. So that is very hard. And the other one is, I would say, end-to-end service product. That's also very good. So my opinion about this is not only focus on just doing some offline things, compute model and software engineering, do the rest of things. So you are supposed to from the scratch data to the final output, and if that was the service, it has
so we all know how important and how critical data science is. As you are going to explain, suppose there are start running some kind of code language, which is not the focus of the understanding. And the founders of data scientists. And the second thing, it's like a sort of career. And also a few years ago, one of the famous magazines, Harvard Business Review said data science is the success.
That's fine. I can take it. Oh, you're saying like what is the best language to start with for business school students, right?
Yeah.
Okay. Yeah. So I don't think it's a big deal because as a language, you learn programming, but you learn a specific language. But as a data scientist, I would still recommend the Python to be a long, because if you're not tend to have deep knowledge of computer science, but you still good to learn like the algorithm and data structure. But if you don't want to go deep, Python is a good start. And besides Python, some languages in statistics and R is also popular, but don't expect it to be very scalable in industry. So Python R is really capable of doing anything. Like people try to integrate with Python with all kind of features, but though it's not that fast. And if you're more interested like in big data, some language like Java, Scala would be also possible. Back to your question, the Python should be
continue the first question. So, as everybody is studying the if he really wants to do this industry, what kind of student?
What kind of what?
What kind of suggestion, for example, idea in college,
kind of features, but no, it's
from
not that fast.
or to set
And if you have more use like big data,
future
some languages like Java.
Yeah, so data science is a multidisciplinary. So it involves computer science, mathematics, statistics, all kind of stuff. But just as an entry level, you probably need to take some statistics first, then for the computer science, there's entry level courses in detail. Then I don't know if you offer like kind of course like product sense in business school, but that is also pretty good in data science. May not be required for the entry level, like a new graduate, it's very nice to have some business sense.
Yeah. So data science is multi-specific.
Yeah, I would say like the algorithms, data structure, database, some query language, simple query language, Python, fast, statistics, like for the linear regression, those adding variations required or probably not. Yeah, I can't give you all the examples, but just those are very entry-level statistical courses.
May not be required for the entry level, but if you graduate, it's very nice to have.
I would like to ask you a question about your insurance model. And I was wondering,
yeah, I would say that,
do you know any What was the result? So did you know, maybe your company saved some money because of this model? So could you point anything that, as a deliverable, that you were able to achieve with that?
So the ultimate goal is always like optimizing the pricing model. We want to give you the lowest money that you can accept while the company is stable. So that's the ultimate goal. And I think it's more like a personalized rate. It's not just giving me your information. Like if your vehicle and your information demographic is similar to some others, and we just give you the same rate. That's not what we want. We want to give you personalized based on what is your driving behavior. Like if you say, we analyze, you have very good driving behavior and take care of your car and in the garage, and you don't drive very far away, we tend to give you a lower rate. That competitive in our state. And also, like I would say, the other ones, they try to give you the really precise number when you search online. Like you just give all the information, they will give you the final price. It's not like, say, you talk to your local agent, you give you another discount. I don't know if that happens to you, but what is happening to many people, like the local agent, they have the best price. And I know some companies have already adopted a very good online model, and if you just type in your information, they will just give you a final best price.
I would say the other one, they try to give you the really precise number.
What would you say are the most important topics in statistics that a data scientist
It's not like
should
you talk to your local agent, they give you another
Statistical.
discount.
Yeah, what would be the most important statistical topics?
Like the local agents, like they have the best price.
A data science.
And I know some companies already adopt very good online model, and
I would say almost every topic requires like the statistical level. When we do model, and you should be able to know like the confidence interval, like the distribution, different kinds of distributions.
Are the most important topics?
And especially like in the some companies when you start using the statistical details or critical. I can't say like which one is the most important. Probably like the normal distribution, you have very good knowledge of that, and you know in which kind of scenario follow which kind of distribution, and like if it's normal, if it's like a Poisson distribution, it's kind of it's not specific distribution, but you know where to apply.
And especially like in testing. Some companies doing experimentation.
So this question may be very naive question, but I'd like to know which computer operating system is the favorable used by data scientists. My question is like Windows, Apple, Linux,
Yeah, that's a good question. I would say it's not that important because before I mainly use Linux or like the Apple, the OS X, that is but when I joined Microsoft, everybody is trying to use Windows. You still get used to it very quickly. Yeah, so I guess there should be no difference. But if you ask, I'm just guessing if you ask, and also data scientists still prefer Linux over Windows.
Yeah, that's a good question.
What's
I would
one
say
skill that
it's
you
not that important
wish you
because
learned earlier
before
to excel your career?
When I use Linux or like the Apple, the OS X, that is command. But when I joined Microsoft, everybody is required to use Windows.
So from my personal experience, I would say it's the project management.
I guess that's
when you assign a given project from the product manager from the client, you will always have the full picture of the project or the progress. You're not just focused on some small piece,
one skill that
try to make it
you
perfect.
wish we learned
And
earlier
while like
today,
for the
so
big picture,
your career?
you're not aware of anything you want to do. So when you're always thinking of the full picture, it's hard to very easy actually to organize the different pieces of the project and always achieve it.
So from my perspective, I would say it's the project management. Like when you assign your given
I'm just curious, have you started using ChatGPT, for instance, in your line of work? And if you could maybe project the future, like how do you think it's going to influence data scientist work in general and maybe in specifically your work?
Full picture.
It's a good question. To be honest, I use ChatGPT for some of my slides. So, I have to admit that ChatGPT is so powerful, so I test that, and it's giving me everything I want. Don't use it to do something. Have you started using ChatGPT for he is so confident in the numbers, control it or not, but just if you let it to give you some descriptions, some introductions, that would be good. So for me, that's why I say for the data science, we try to take ownership of the whole project, not just focus on modeling, not just focus on like feature engineering, because those are very my thoughts are very easily replaced by ChatGPT. But the part that it cannot easily replace is the logic thinking. And when you do the project, you will make the step by step, and for each part, you apply the human intelligence to make it logical. So with ChatGPT, it's kind of like you still need people to validate the process. It can help you for small tasks, but if you ask you to do a big project, you will still need a lot of human effort to do the validation and to see if it is reasonable. But in the future, like if the ChatGPT is evolved so quickly, you can have the logic thinking and replace all the work. I think your question is not to data science, it's to all the industry, the work we should do. So yeah, so my thought is like try to demonstrate our value, like why the data science is the real value. It's not just about
it can help you to produce small tasks, but if you ask you to do a big project, you will still need a lot of human
overall,
to do the validation.
It's really accelerating all the technologies.
But in the future, like if the ChatGPT,
what kind of regulations or procedures are y'all following when it comes to advancement of AI? Because you have people who are really high up in politics or working on get involved or slow down AI because they're advancing too fast and not really learning what procedures are put in place to make sure you have all that control. Then you have people, companies like racing against each other, like for example, the space race back in the day, we want to kind of catch up to Microsoft. And they're just trying to go up back in and just trying to get it pushed out there.
Yeah, that's a good question. But I think I'm at the same situation as you. I don't know. Yeah, so that's just like too much discussion about AI, and I don't think I'm an expert who can really say something. So I can talk a little about the privacy, the regulation of privacy, like each company for our data science, they have really much effort on privacy and department to do that. So for our data science, usually it's like we are given data, but we have no idea where the data from, who has the data is from who. Yeah, sorry, I just can't.
No, you're right.
That's a good
really, say something. So,
I would be interested. I'm a political scientist here. I'm visiting scholar at GSU from the children level. But in my classes from home, I'm teaching R and statistics in R for political science. But I'm sending my students, my graduates, to a private marketing companies, and they do very basic stuff. But since they're from Microsoft, is there any chance for a social scientist major to work for Microsoft as a data scientist who knows just the basics? I mean, like basics in programming R or Python. I'm now thinking about switching from R to Python because Python is more common across the data analysts. But European Political Science Association, they run everything on R. So is there like a prospect for a political scientist or social scientist to apply for a job for a Microsoft company?
Yeah, that's possible. Because Microsoft is not just have data scientists, like if you want to use data scientists, like they are data analysts or business analysts or data engineering, so all kinds of work which might fit your expertise. Like for social science, you are familiar with R, and if you have some business sense or like reporting and stuff, it's also possible. Like for me, I'm not graduate on this physics, I'm graduate physics. So as long as you have those techniques, those courses, and you have and you start with the internship, that's much easier. But like if you say that you are graduate with social science, you use R, and I want to apply directly with data science, that's kind of a little bit difficult. So I would say like the slower transfer, starting learning the courses, and then those techniques, and apply for internship, that should be easier. But for the programming language, I don't think it's a problem, because I used R for a few years, and then I just switched to Python, and I use Scala, and it should be no problem.
IBM SPSS person used to be. Then I figured out that I had to completely switch because IBM SPSS is now used to more advanced stuff. And now when I learn R, like I'm like in a way that I should also learn Python. Might be more beneficial for my students.
R is no easy easier than Python. If you master R, I used R for a few years, and then I just switched to Python.
This is also mentioned the question Before we wrap it up, probably I'm going to take one more question from the future series. And also, before we reach this last one, we might ask you to have a planning to show our appreciation to the program, and also when we have a teacher So, do we have any questions from the...
Nope.
Right, and I really appreciate Dr. Wu's wonderful presentation, and thank you for your time. Very appreciate here. And again, like I said before, this is time to appreciate Dr. Wu's presentation. So please give us a quick hand. So, do we have any questions from the...
Nope.
Okay. Right. Then I really appreciate Dr. Wu's wonderful presentation, and thank you for your time. I really appreciate to be here. And again, like I said before, this is time to appreciate Dr. Wu's wonderful presentation. So please give a big hand.